Hello viewers, you're welcome to my YouTube channel. In this video, I'm going to be solving this equation. It looks complex, but we're going to break it down one step at a time. So let's start. Now, the first thing I'll do, look at the left-hand side of this equation. What I have is the x root of what? 2 over x minus 1. Now, we're going to use one of the laws of indices. If you have let's say you have the nth root of a, this is equal to a raised to the power of 1 over n. Or if you have a raised to the power 1 over m, this is equal to the mth root of a. So the denominator of this fractional index is the root. Why am I saying all of this? Because coming here now, I can rewrite this. If I don't want to use this radical to express this root, I can write it like this: 2 over x minus 1, all raised to the power of what? 1 over x. This denominator is the what? X root, as you can see right here. So good. Let's keep on going. Now this is going to be equal to what? X minus 1 on the right hand side raised to the power of what? X minus 2. Now again, from one of the laws of indices, if you have a raised to the power a over b raised to the power m, this m, which is the exponent, can be distributed to a and b. So we can rewrite this as what? A raised to the power m over what? B raised to the power m. That's exactly what I will do. So I'm going to write 2 raised to the power of 1 over x over what? X minus 1, all raised to the power of what? 1 over x. Okay, so this is equal to what? X minus 1, all raised to the power of what? X minus 2. Okay, so what am I going to do next? I'm going to cross multiply. So I'll have it like this and like this. I'm going to have 2 raised to the power of what? 1 over x is equal to x minus 1 in bracket raised to the power of what? 1 over x times x minus 1 raised to the power of what? X minus 2. Now what can you see? They have the same base. This is x minus 1 here, and this is what? X minus 1. So using the product rule of indices, because they have the same base, I am going to add their exponents. So 1 over x plus what? X minus 2. So let's rewrite this like this: 2 raised to the power 1 over x is equal to x minus 1 in bracket, and then was 1 over x plus x minus 2. I just added the exponent because they have a common base. So let me now take the x power of both sides. Why am I doing that? Because I want to get rid of 1 over x here. So to do that, I have to multiply the powers, the exponent, by what? By x. So we do that here, and we also do that right here. So see it here and see it here. Now what's going to happen here? X will cancel x, and I just have what? 2, which is equal to. Now let's use this x to multiply every single term we have in this bracket. All right. So you tell me now, what is x times x? Or maybe I should write it like this. So that will be x minus 1 raised to the power of what? 1 over x times x. Remember, I'm using this x to multiply every single term in the bracket. So it's going to be what? Plus x times x, and then minus 2 times x. I just use this x to multiply every single term in the bracket. So let's keep going. This is going to be what? 2 is equal to x minus 1 raised to the power of what? X will cancel x. So I have x times x, which is what? X squared. So I have 1, because if x cancels x here, it's going to be 1. So 1 plus x times x is what? X squared. And then minus 2 times x is what? Minus 2x. Good. So this will be 2 is equal to x minus 1 all raised to the power. Let me just rewrite it. This is already a quadratic expression. That will be x squared minus 2x plus 1. This is a perfect square. How do I know that? Now let's bring it out. X squared minus 2x plus 1. To test if this is a perfect square, look at the middle term here. What is the middle term? The coefficient is what? Negative 2. If you half it, that's minus 2 divided by 2. What are you going to have? Minus 1. When you square it, what are you going to get? 1. And what is this constant term? it is 1. So this is how you know if an expression is a perfect square. Another thing again you can do is if b squared is equal to 4ac. If b squared is equal to 4ac, or if b squared minus 4ac is equal to 0, using the discriminant now, you can tell if it is what? A perfect square. But let's quickly see that. Is it true that b squared would be equal to 4ac? What is b here? B is negative 2. So negative 2 squared is equal to 4 times a is the coefficient of x squared, that's 1, times what is c? The constant term, which is 1. What is negative 2 squared? 4. And what is 4 times 1 times 1? That's 4. So can you see that 4 is equal to 4? And this makes it a perfect square. So how are we going to write it now? I'm going to write it like this. Just watch. So this will be what? 2 is equal to x minus 1 raised to the power of what? X minus 1 all squared. Can you see that this is a perfect square because it has a square there? You can apply square root on it and you still get a whole expression. Very good. So what are we going to do next? Look at this 2 here. Do you know that 2 can be expressed like this? Root 2 raised to the power of 2, because root 2 raised to the power of 2 is root 4 and root 4 is 2. All right, so I'm going to express 2 as what? Root 2 raised to the power of 2, because I'm having a base here and an equal exponent of x minus 1. So let's do that. This is going to be what? Root 2 raised to the power of 2 is equal to x minus 1 raised to the power of what? X minus 1 raised to the power of 2. But I still have a challenge here, because what you can see here is that root 2 raised to the power of 2. But what do we have here? X minus 1 and what? X minus 1. So for us to be able to equate them, it has to be equal. What I have here and here must be equal. So again, what I did to 2, I'm going to do it to this 2 here. So I will write root 2 raised to the power of what? Root 2 raised to the power of 2. This here will give me what? 2. So I can write it like that. Can you see how this will just match with what I have on the right hand side? So this is equal to what? X minus 1 raised to the power of what? X minus 1 raised to the power of what? 2. And as you can see, they compare at this level. See this, identical, and even the 2 as the topmost exponent. So what are we going to do now? We can cancel out the square on top, and then we have that root 2 raised to the power of root 2 is equal to x minus 1 raised to the power of what? X minus 1. So what does this mean? It means that x minus 1, or let me just say root 2, is equal to what? X minus 1. Because this compares with this, and this compares with this. So what I will do next is to transpose negative 1 to the left-hand side, so that we'll have an expression or a value of x. That will be root 2 plus 1 is equal to x. Now, therefore, x is equal to root 2 plus 1. So this is the value of x that will satisfy that equation. I hope you found value from this video. If you did, kindly subscribe to this channel and share this video with your friends and family. I'll see you in the next one. It's bye for now.